Okay, here we are with Jason at the 1 Watt house, who has and Jason has designed and installed this 2 heat pump and energy recovery ventilation system. Brilliant work, and he's going to show a few characteristics of the HVAC system, which makes it very interesting. So go ahead, Jason.
Okay. In the previous video, we talked about having a passive laundry drying closet that's tied into the ERV system. Also, the bathrooms are tied into the ERV system. The ERV system always draws from the bathrooms. You have the option of boosting that air. Normally, it's minimum airflow of around 40 CFM, which meets our code requirements. And in the event that you need to move more air out of the bathrooms, you have the option of hitting a timer in either bathroom, which then boosts the output from the ERV.
And where is that ERV?
That's right to my right now. This is accessible from the mechanical room.
Let's take a look. Let's swing around here and just take a look. This big black box here, then.
That's correct.
With those 2 pipes.
It's really accessible from the mechanical room. As I'm standing on a ladder, you're able to access the filters to it and the media that actually does the actual work.
Oh, okay.
We were talking about the laundry closet, and you also have a common area that you might want to pull still air from, which is the kitchen, the living and dining rooms.
Okay, and that's through here. Here's our open area here, which is that's all open. So that's the common area, and so that's one zone or one heat pump.
There's one heat pump that takes care of that area, plus the library, which is on the opposite end from where we're standing. The other unit takes care of the master bedroom where Dave is standing, the master bath, the laundry room, the second bedroom, and the hall bath. Back to the ERV, we were talking about the fact that it always draws from the bathrooms regardless. However, you have times you might want to pull air from somewhere else, like the laundry closet or the common area, in which case each of those areas have a timer that actuates these zone dampers. This zone damper is coming from the common area.
Oh,
it's typically closed unless
that little box on the bottom of the
box is actually the motor that opens and closes the damper that's what's inside of the pipe.
Okay.
We've got that one is for the common area in the kitchen. This one behind it, it's going to be hard to see from your vantage point.
Oh, I see it. There it is. Yeah.
This one is the damper for the laundry closet.
Okay.
Which is always closed unless you're drying your clothes in the closet.
Okay, so that one will always be closed unless we open it with a special switch.
That's right. The same is true with the common area.
Okay.
That is designed that way so that we can always draw air from the bathrooms and do it with the ERV on low.
Okay, so in other words, the ERV is always exhausting air at about 40 CFM or 50?
Per bathroom. Yeah, it's about 90 total and low. So we're dividing it between 2 bathrooms. So we're going to have around 40, 45 from each. We've got the master bathroom is pretty large, so we may want to draw more air from that from time to time. So we have the option of pressing a timer on the bathroom wall, which boosts the output of the ERV to about double what its low range is, so it's going to pull about close to 200 CFM on high.
Okay.
And that will then pull basically 100 CFM from each bathroom unless you have the closed drying closet open or the common area open. If you were to activate one of those, it's going to open the damper and also activate the boost function on the ERV, which will then increase the airflow to its maximum.
So literally we could keep this flowing all the time.
It does flow all the time.
It does flow all the time, and if we open the windows in the open area, it's okay. We have natural ventilation, and but we're still drawing exhausting air from the bathrooms, and we would be perfectly fine in that case.
That's right. It's a code requirement. You have to have exhaust fans in the bathrooms, and they have to pull a certain amount if they're continuous. If they're intermittent, they need to pull more, typically 50 CFM or more, if they're in intermittent use. You can get away with not having bath fans if you have windows, but who wants to open a window in the wintertime to use the bathroom?
Right.
So the other part of this is instead of having dedicated exhaust fans that draw air and just shove it out of the house, which then would have to be made up through infiltration, this is one thing this home is trying to get away from is infiltration. This home is extremely sealed, and that is really the need behind the ERV. With the house being as sealed as it is, without the ERV, it would possibly be a sick home. But with the ERV, you're replacing all the air hourly. So
we have a constant infusion of fresh air and exhausting stale air,
while exchanging the heat and moisture energy between the two paths, so that you're not wasting that energy.
Wow. Okay. Brilliant. Let's see. Any other thoughts? Actually, this ductwork is just beautifully done, and you've made it all airtight by sealing it with some sort of mastic. Okay. So if we look real closely at these joints, we see they've been painted with the mastic to make them airtight.
And that's just so that all the ductwork is in conditioned space. If we were to leak some air, it would not be a critical error. However, it is nice to know where every CFM is going. So with all the ducts sealed, when we balance the system, we're going to have be able to divide up our maximum airflow, which is going to be around 370 CFM out of each unit. We'll be able to put every bit of that air into a room where it needs to go, rather than restricting the system by balancing it and then having some of it lost through cracks and seams.
Oh, beautiful. Well, that's fantastic. Thanks a lot, Jason.
You're welcome.
We'll see how the house performs at some point and kind of recap everything when we get drywall up and just see how well all of this works. And so thanks for checking out our video.